Hello, I'm Carly McAvoy. I'm looking at systems of equations, the elimination method revisited briefly, and then some special cases. So the system of equation that I have here would not be easy to substitute. By the time we rearrange it, we'd get some awkward fractions. So I want to eliminate, but notice if I wanted to add these together, nothing would be eliminated. So what I want to do is multiply both of those equations by something to get something to go away. So what I'm going to do is eliminate the x's. So what I want to do is multiply the top equation and the bottom equation by something so that the two coefficients will be opposites of each other. Since I have 3 and 4, the first common multiple I could have would be 12. So I'm going to multiply the top equation by -3 and the bottom equation by +4. And that's going to give me the negative and positive 12s that I want. -3 times 4 is -12x. -3 times -3 is +9y. And -3 times 9 is -27. Notice I had to multiply the entire equation by -3, not just one term. 4 times 3 is 12x. 4 times 5 is 20, but I have a minus there, so -20. And then 4 times 26 is 104. Now I have opposites, and now I can add those two things together and eliminate. So those go away. 9y minus 20y is -11y, and 104 minus 27 is 77. Divide both sides by -11, and I get y equals -7. Now remember, that's half of our answer, because our answer for a system, if there is a unique solution, is going to be an ordered pair. So I found half, but I haven't found the other half yet. I'm going to go back to either one of my equations. I'm going to pick this one. 4x minus 3 times -7 is 9. If I solve that, now I'm going to find out what x is. So I have 4x plus 21 is 9. And if I subtract 21 from both sides, I get 4x equals -12. Divide both sides by 4, and x is -3. So I get -3, -7. Now, before you move on, you could quickly check that if you wanted to. If we're saying that x is -3, then I have 4 times -3, and y is -7. 3 times -7 should be equal to 9, and that's -12 plus 21, which is 9. That's true. I could check also the second one. 3 times -3 would be -9. -5 times -7 is +35, and that's supposed to equal 26. 35 and -9 does equal 26, so that checks as well. It has to work in both equations for it to work. Okay, that was not a special case. In the special cases, you will see that both of your variables will be eliminated. If both variables are eliminated, you have a special case. One is they eliminate to leave you a true statement. That means you have an infinite number of solutions. In the other case, they eliminate and leave you a false statement, which means no solution. All right, so let's see what we have here. Up here, you could use the substitution method, or you could use the elimination method, whichever you prefer. Since I just used the elimination or addition method, I'm going to use substitution. I'm going to take this equation on the top and add 6y to both sides. And that's going to allow me to substitute into this expression, into this equation, excuse me. So where I had 2 times x, I'm going to replace the x with what I now know x to be, which is 10 plus 6y. And now if I distribute, 10 times 2 is 20, and 2 times 6 is 12y. And now if I do 12y minus 12y, I get 20 equals 20. Both of my variables are gone. The first one I got rid of by substituting. The second one was eliminated along the way. So both of my variables are gone, and I'm left with what? A true statement. True statement means that I have an infinite number of solutions. And what does that mean if you were looking at it in a graph? If you were looking at it as a graph, you would graph one equation and the second one would fall directly on top of it. This one would have a positive slope, so they would both be going up. Both of those are the same equation if you went to graph them. So every point is a point in common along there. I can't just say infinity because there's a bunch of points that aren't solutions to that, right? But there's an infinite number that are. Okay, let's look at this one. I'm going to use the elimination method again. Since I just used something different, I'm going to eliminate the x's. So I'm going to multiply by -2. Negative 2x plus 2y is -6, and 2x minus 2y is -1. Now when I add those together, the x's go and the y's go. They cancel out because they're both additive inverses, and I get -7. So now I say, whoa, both of my variables have been eliminated. What does that mean for my answer? Well, you have to look to see, were you left with something that was true or something that was false? This is false. False statement means no solution. So this is no solution. What does that look like if you were to graph it? Well, what it looks like is parallel lines. One runs along beside each other, but they never touch. Therefore, there's no solution because a solution to a system is where they intersect. Okay, one more. This one's definitely set up for substitution. So I'm going to use substitution, and I'm going to take this second equation, x plus, and where I used to have y, I'm going to replace it with -x plus 1. And I get -x and positive x goes away, and I have 1 equals 6. So what does that mean? It means I have, again, no solution because I had a false statement. You have to look and see, were you left with something true or something false? Okay, one last problem here, and this one you could choose to work without me and try it and then come back and see how you did, or you can stick with me, but you always do learn more by trying something different. And this one I'm going to use, I'll use addition method or elimination method since we just did the other one. So I'm going to eliminate, let's say, the y's. I'm going to multiply this bottom equation by 3. So I'm not changing the top equation. I don't need to because I already have 3y, and multiplying down here is going to give me -3y. So 3 times x and -3y and 6. So I'm adding these together, and I can do this because now these eliminate, and I get 7x equals 0. So here's where some people say, okay, is this, false or whatever? But no. Read this part again. If both variables are eliminated, you have a special case. Look at us. We didn't eliminate everything down here. We still have x's. If you don't eliminate everything, you don't have a special case. You just have one unique intersection point. If you divide both of these things by 7, you get x equals 0. 0 is a completely legitimate part of an ordered pair. So we have x is 0. Then we can go back and say, well, what would y be? You can plug into either equation. That's just 0. 3y is -6, and y is -2. Before I go on, I could quickly check it. 4 times 0 plus 3 times -2 should be -6. Yes. And 0 minus -2 should be 2. And 2 equals 2. Yes. You can always plug those back in to check. And there's some special cases, and sometimes 0 throws people, so don't be led astray by that. And then just a kind of a difficult problem with the elimination method. Have a fantastic day.